Water is the reactant for hydrolysis reactions that occur in the body. Starch is hydrolyzed in the mouth by the enzyme salivary amylase. With the help of this enzyme, water molecules are added to the bonds between the glucose units in the starch, hydrolyzing the starch to glucose. Note that water can also be formed during some chemical reactions in the body, such as the reactions that produce metabolic water. Water acts as a solvent to dissolve molecules and ions in the body. For example, if you eat a salty pretzel, the water in your saliva will dissolve the salt. Water is a polar molecule. When water dissolves ions, the partial negative charge on the oxygen attracts positive ions, such as sodium, and the partial positive charge on the hydrogen attracts negative ions, such as chloride. Except for the salts deposited in bone and teeth, most other ions in the body are dissolved because of water's ability to act as a solvent. Water within cells is an important solvent. It dissolves many of the proteins and other solutes. You are looking at plasma, a typical body fluid. The term body fluid refers to the water in the body and all of the dissolved substances, which are also known as solutes. Since the water dissolves the solutes, it is the solvent. A typical body fluid contains electrolytes, also known as ions. Proteins are considered to be colloids when dispersed in body fluids. Compared to simple ions, proteins are huge molecules. Because they bear a negative charge, we will consider them to be electrolytes. Non-electrolytes are uncharged molecules found in body fluids. Glucose is an example of a non-electrolyte. Blood cells do not dissolve in water. They are suspended particles and are not considered to be a part of the body fluid. Electrolytes are charged particles or ions that are dissolved in body fluids. The major positive ions or cations in body fluids are sodium ion, potassium ion, calcium ion, and magnesium ion. The major negative ions or anions in body fluids are chloride ion, bicarbonate ion, phosphate ions, sulfate ion, anions of organic acids such as lactate and proteins. Which pH is more acidic, pH 4 or pH 8? The answer is pH 4. The lower the pH, the greater the acidity. When hydrogen ion increases, acidity increases, and pH decreases. When hydrogen ion decreases, acidity decreases, and pH increases. Which pH has the greater concentration of hydrogen ion in it, pH 7 or pH 8? The answer is pH 7. When a solution has more hydrogen ion, it is more acidic, and it has a lower pH. Remember, when we increase or decrease the pH by 1 pH unit, we are changing the concentration of hydrogen ion by a factor of 10. So there is 10 times less hydrogen ion in a pH 8 solution than in a pH 7 solution. Recall that hormone is a chemical messenger that is released into the bloodstream. Most hormones can be grouped into one of three classes of chemicals: peptides, amines, and steroids. First, let's talk about peptides. Hormones made from chains of amino acids range in size from small peptides of just 3 amino acids to small proteins containing more than 20 amino acids. For simplicity, we will refer to all of them as peptides, a convention used by endocrinologists. Most hormones are peptides. They are water-soluble. The amine hormones are derived from the amino acid tyrosine. Dopamine, norepinephrine, and epinephrine are called catecholamines. They are formed by a series of chemical reactions that modify tyrosine in successive steps. Catecholamines are water-soluble. two iodine-containing molecules, thyroxine or T4, and triiodothyronine or T3, jointly form the thyroid hormone. Each is produced as iodine is added to thyroglobulin. T4 and T3 are lipid-soluble. The steroid hormones are derived from the molecule cholesterol. Steroids are formed by a series of chemical reactions that modify cholesterol in successive steps. Steroids are lipid-soluble.